Hello everyone, this is a live stream Commodity Supply Chain Management Week 2 Lecture 2 and tonight I'm going to go over the inventory. I think last night when I did the lecture 1 of Week 2 on inventory, I realized there's a lot of material to cover one night and also 1 week. So what I'm going to be doing tonight is going over the inventory homework and just talking about what it means, how to work it, and so that it'll help you prepare to submit it this Sunday. Okay, and also like a live chat, this is like a lecture. So I do have a chat room, and so live stream is like a lecture. You have a chat room, you can ask questions as we go through this, and that way we can engage. Okay. Now, a little bit of introduction, bring up the syllabus. Coming down here, we're right here in week 2, which is inventory. And also August 30th, this Sunday, homework 1 is due. And this is the homework I'm going to go over. If we bring up the canvas, an open canvas, you see down here, week 1. Here's week 2, August 24th. And this the live stream is where I'm at now, and the Zoom meeting we're going to have this live stream instead. And also here's the questions. So I'm going to download these questions and go over these questions before try to go through them, and I'm not going to work them all the way through. I'm not going to go talk about the answers, but I do want to talk about here's where you find the material, here's how you would set it up, here's how you would go through it. And I'd work it almost to the finish, but I'll let you finish it. So I'm usually not going to, I might go all the way through if I don't pay attention, but I'm going to set it up so you know how to work it. And this will be recorded, posted it as a video, and there'll be a link right here below this one, a link right here that you can go to a video and watch it. Okay, so I tell you what, let's download this homework and get started. And talk about the homework. Open it up. Let's go actually full screen. I've already opened it up. Let's open it full screen. There we go. Okay. Now going through the homework, I have the instructions here to make sure that you do not submit it until you get all the answers. There are 2 versions for some of the questions, most of the questions in this homework assignment. Version A is quantitative, version B is qualitative. You may work either one or both because the answers are the same for both versions. And so I mentioned this on Monday, and I want to emphasize it tonight. In other words, last night. I talked about it last night. I indicated that last night. Tonight I want to emphasize it. And you'll see version A, version B, one's quantitative, one's qualitative. But then I began to realize when I went through the material, in order to understand the qualitative, you really need to understand the quantitative because they kind of go hand in hand. And you can understand the quantitative without the qualitative. You can understand the qualitative without the quantitative. But you really need to know both in order to understand both really well. And so the whole point of tonight is to really understand this material before we get into the other types of supply chain analytics and supply chain management within the commodities. Okay, I start here with an overview, an outline of takeaways here. I'll be talking about these, and the objectives is high service levels, low cost with continual improvement, and also the main topics. Now in these main topics 1 through 10, this is pretty much what I'm covering, but here it's like a summary of the equations that we'll be using, and some of the applications, some of the qualitative come from understanding the relationship in the equations, in these expressions. ROP, EOQ, continuous and periodic. For stochastic demand, you have the lot size and ROP. For the periodic review system, just the base stock level is all you have. And then single period, we'll look at this, okay? And then risk pooling, echelon inventory, and ABC classification. Last night when I got down to here, I began to realize this is a lot of material, okay? But it's good material, and it's important to take time to go through, and so I'll spend time tonight to go through it. So there's where we are. So let's get started. Okay, question 1, the same version, the same questions for both versions A and B. So question 1 is the same, okay? And so essentially all I'm doing here is just, sorry, if I bring up the lecture, here's a lecture. Remember, at the very beginning, I go over these definitions, okay? And all I'm doing here is just going through these definitions. And so from the lecture last night and here, it's just pretty much the definitions, okay? Question 2, again, this is for constant demand too. Okay, where am I saying it? For constant demand, constant demand, constant demand, constant demand. So that's the combination concepts behind just inventory period, lead time, ROP, this kind of thing. Now down here on question 2, I do essentially the same thing, but it's for stochastic demand. Stochastic demand, stochastic demand, stochastic demand. So question 1, question 2 is just terminology, definitions, language for the constant demand and stochastic demand. But then now I get into the quantitative, and let's back up here and notice what the quantitative is going to be pretty much the constant demand and then stochastic demand. But I have version A, version B. I'll talk about the numbers and talk about the interpretations. So let's do question 3 down here. Question 3, version A and version B. Version A is quantitative, version B is qualitative. Okay, here we go. Consider a constant demand of 3,040 items per year. How many statements are correct? So notice what I say here on these statements. Here's an inventory policy. When you have two numbers, it's continuous review system, ROP and Q. And here the lead time is 1.3 weeks, safety stock is 10. So the demand is in years, lead time is in weeks. We have to do some transformations here. The inventory policy, when you have time and then a lot size, that's periodic review. And the annual order frequency is 20. So therefore we can use this. Okay, Andrew, are there definitions typically worded verbatim on the homework as in the lecture notes, or are changes considered to be false typically? Thanks. It's not necessarily verbatim, not at all. For example, turnover rate, turnover index, turnover ratio, turnover constant. So all different terms are being used. And so a lot of it has to do with the context within which it's used. So people rarely do they talk, we do talk about turnover, like an ABC classification. But if we're talking about inventory policies, usually it's the turnover rate. And I'll say turnover rate. I'll try to be as consistent as I can in here. But sometimes I'll use a different term. Now, in industry, they do all different things in industry. Okay, so you have to be careful when you start using this at work. What do they really mean by that? And a lot of times there's a culture around it. People will use the same term all the time and they mean a certain thing. So a lot of times you'll have a culture in a company. Make sure you understand what it means. Okay, I hope that's what you mean. Okay, for the optimal, that's the OQ. Okay, the optimal inventory policy 86-173. The inventory period is approximately that. For lead time of this, safety stock, then talk about cost. So there's a number of things I'm doing here. Okay, first of all, let's do it down here. First of all, this one up here is ROP. Well, I'll tell you what let's do. Let's come back up here, since I already have these things here. Let's talk about these. Okay, bingo. Wait for it to copy. There we go. Let's come down here and let's put it right here. Bingo. Geez, where'd it go? It's there. It just doesn't like, it just isn't. There we go. Let me put it down here. There we go. Okay, so I'm using this for the lot size, this for the RLP, this for the EOQ, and so all these are in the statements 1, 2, and 3. Now, one thing I want to point out here, and you just plug and crank is what you do, because this is RLP, this is the lot size Q. For the optimal policy, this is RLP, and this is the EOQ. Okay. So what we're doing here is we have items per year, but here we have 1.3 weeks, and here we have item cost per quarter. So we're going to need demand different times. Okay. And so the idea here, let me input this. The conversions are going to be important here. So you're going to have a year, you're going to have a quarter, you're going to have a month, and you're going to have a week. Okay, and then here's your demand. Okay, and we have 3040 per year. Whoops, 3040. So per quarter, it'll be 3040 divided by 4. For month, it's 3040 divided by 12. For week, it's 3440 divided by 52. So that's the demand you use if you're using weeks, if you're using quarters. So you have to be careful with it, with the time units. And I recommend going from year down because that's the easiest way to do it. Okay, and so the question is this true? Okay, well, if the lead time is 1.3, we have the demand, we have the lead time, we have the safety stock is 10, okay? And so is the ROP then equal to 86? Good question. Okay, it's not really asking about the lot size, but for inventory policy of this 1.2 months, the annual order frequency is 20. Okay, so if you're ordering 20 a year, again, you're going to divide by 4 to get a quarter, divide by 12 to get a month, divided by, well, we're talking about months here. So we'll divide by 12 to get a month. Frequency per month. Now if order once a month, it'll be 12 a year kind of thing. 12 a month, 1/12 of a year, 1/12 frequencies. And so the thing of it is an order frequency of 20 per month the same as is it going to give you 304? Actually, we don't need the inventory period. I guess we do. So this is the inventory period, and this is the order frequency. Remember, let's do this. T equals 1 over F. Okay, and so this is annual, this is month. Divide this by whatever 12, and take the reciprocal. Is 12 over 20 equal to 1.2? Okay, and then the optimal here, inventory period is this. For the inventory period, I just now realized another good reason to go through this. I do this so fast. I just realized, say, an optimal inventory policy. That means this is EOQ. So we know that's EOQ. Okay. The inventory period is 5.2 weeks. Well, if that's EOQ and the inventory period is 5.2 weeks, so this is 173, this is 5.2 weeks, and the demand here is 3040, then does that fit? okay, then is the ROP equal to 86. Okay. Unfortunately, you don't know what the safety stock is. I don't think you can answer this. You almost could if I had given you so this is 86, you know demand, you know this, okay, you don't know, there's two things you don't know, lead time and safety stock. Okay, statement 3 you can't answer. Bummer. Oh well. Oh well, that's a problem. Okay, and what I should have done, I should have given you either the lead time or the safety stock right here. I have to give you either lead time or safety stock in order to answer the question. Okay. Now here I am giving you lead time. I'm giving you the safety stock. I'm giving the ordering cost, carrying cost, and I'm saying the total inventory cost. So if you're given all of this stuff, then statement 4 can be answered because with the lead time and safety stock, you can get the ROP. Okay. And then with the ordering cost and carrying cost, you can get EOQ. So you have ROP and EOQ. From that, you can determine your costs. But as it turns out, I'm not going to change this because this number, statement 3, can't be answered. I'm pretty sure here. The inventory period is if the optimal policy. Oh, yes, you can. If the optimal inventory policy is 86,173, then the inventory period is approximately 5.2 weeks. Okay. Well, the inventory period is going to be T. So the thing of it is that if Q is 173 and if T is 5.2, well, if Q is 173, does that imply that T is 5.2? So yeah, you can. You can. Okay. So the demand here, if the demand's in weeks, so essentially what you do here, T is going to equal Q over D. I should have reviewed this. I haven't seen this in a while. Q is 173. Okay. Now T is in weeks, right? So the demand has to be in weeks. Okay. Divided by the demand in weeks, which is going to be 3040 divided by 52. So the question is, does that equal 5.2? Good question. It's approximately 5.2. So you do the arithmetic, see if it's 5.2. If it's true, then it's true. If it's not, then it's not. So you can answer that. So I take that back. I just have to think about it. Okay, now this last one is calculating the total inventory cost for the minimum cost inventory policy. So you get EOQ here, 2 times your demand, times the ordering cost, which is given right here, 128. Carrying cost is per quarter, so your demand up here has to be in quarters. Okay, so this is going to equal the square root of 2 times the demand, which is 3040, divided by, so when we do quarters divided by 4, that's demand per quarter, times the ordering cost, which is 128, divided by the carrying cost, which is 6.5. Okay, so that's going to give you Q for that problem. So you know what Q is. Okay, the lead time is 3 months, safety stock is 10. So for ROP up here, that's going to equal the demand. Now remember, let's see, lead time is in months. Again, the demand is in months. So I have the demand, 3040 divided by 4 in months, times the lead time, which is 0.3, plus the safety stock, which is 10. Okay, so that's going to be the ROP. Okay, but notice that the ordering cost. So now what we want here, let me put it right here. We want the total ordering cost plus the total carrying cost. Okay, so the total ordering cost is going to equal the frequency times the unit ordering cost. Okay, and the frequency is going to be this EOQ. Remember, the frequency is D over Q, so it's 3040 divided by the EOQ, whatever that is. Okay, times C sub O, which is 128. So that's how you get the ordering cost. Now I'm going to add that to total carrying cost. Okay, now the total carrying cost equals Q over 2 plus the safety stock times the unit carrying cost. Well, Q is EOQ over 2 plus the safety stock. Well, the safety stock is given to be 10 times the carrying cost. Now I want the annual, this is the annual inventory cost, so I want the carrying cost per year, but this is per quarter. Well, if $650 a quarter, it's going to be 4 times that for the year. So this is going to equal 4 times 6.5. Okay, and then you add those two together, and you're going to have, is it equal to 4758.25? Don't know. I'll let you finish that off. Okay, so this is just mechanics of getting used to these things. Now, B down here, I'm saying relationships. If the safety stock increases, then the reorder point decreases. Is that true or not? As this inventory period increases, the order frequency decreases. Is that true or not? So all these are just relationships, okay? And so the reason I did the version A and version B is the relationships are, you have to kind of go into, be careful how the relationships go, increase and decrease. But then once you get an answer here, which is either 0, 1, 2, 3, 4, that answer is going to be the same answer up here. If 2 of these are right down here, 2 of these are right up here. If 1 is right down here, 1 is right up here. And so if you have one answer down here, another answer up here, then you say, wait a minute, something's not right. So you go back and forth. So you notice how my point here is resolving the quantitative with the qualitative. Make sure they work together. Okay. So that's question 3. Now question 4 is stochastic. Lead time, inventory period, stock out level. Consider inventory policy with a normally distributed weekly demand. So now I have a stochastic demand. Okay. And again, version A, version B. Now on this, you're going to need, and use the sample variance, you're going to need the mean and variance. Okay, so let's reduce this down. Let's bring up Excel. We'll be using Excel there. Open, open, open. There we go. Let's bring this over. Okay. There we go. Okay, we're going to be using Excel. And so what we'll do, all we need is the mean and variance of this. So we take this, Control C, okay, and then open Excel. And let's put it right here, Control V. And there it is. Let's increase this so you can see what's going on. And so really all I want is the average. I'm going to go ahead and do this for you. And you do this. Usually I'll say just return and you'll get it. It's going to be 447. Is that right? Let's see, did I get them all? Yes, I did. Okay, and then the variance dot sample variance, and that's going to be all of these. Okay, bingo. It's going to be that. Let's bring this back down. Okay, now that we have the mean and variance, then we'll say, okay, okay, something's not right. Yeah. General. Boom. Let's take this. Control C. Paste it with the values. And then do these again. Interesting. 467, 412, 426, 480, 507, 47, 41. Okay. And there they are. Good. It's the same. Good. Just making sure. Okay, so now from that, you come down here is the reorder point is approximately that. The lot size is that. Base stock level is that. Safety stock is that. And either somewhere they're all either they're all wrong, they're all right, or 1, 2, 3 are right. Okay. Now the idea here is let's bring this out and bring this over here. Let's bring down the stochastic right here. There we go. We'll be using that here on this one. There we go. Okay. Now for the reorder point, you're going to need the reorder point is this equation right here. Okay. So now you need the mean, you need the standard deviation, which is the square root of the variance. The lead time, let's see here, is given up here, and you need z. The stock out level is 10%. Okay, and so essentially what you'll be doing here is like for the ROP. Let's bring this over. For the ROP, let's say ROP. That equals the mean, which is that, times the lead time, which is 1.5 weeks. Okay. Plus z. Now the z is the normal standard inverse of 10%, which is 0.9. You want the inverse of that. Okay, and then times the square root of the variance, which is the standard deviation, times, well, then let's say times the lead time, which is, where was it? 1.5 again. Okay, and you return that, and that's ROP. Okay, I'll let you do that. But the thing of it is that equals the normal standard inverse of 0.9 is like the 1.282. And sometimes I'll just say just use 1.282 and round it, you know. But these calculations that I do here, I use all of the significant figures to do that. Now the lot size here is just the mean. Where's my? It's just going to be the mean here times my inventory period. 4.6 times that. Now the base stock level here is going to be these numbers. So we have the mean, we have the standard, we have the z, we have the t and the LT. It's all in weeks. And so you plug and crank. And then the EOQ, again, you plug and crank. And there you go. Base stock level is this. Use this equation. The safety stock is approximately 57. Essentially, I'm just calculating this right here. Okay. And so how many of these are right and how many of those are wrong? Okay. Now these down here, again, this is really referring to these relationships. And I kind of emphasized then, like as takeaways as we went through on last night. Continuous review system for stochastic requires form of continuous monitoring, and I talk about that. Okay, well suited for a high mean, low variability, and so the periodic. I talked about when they're used. So this is just matching it up with the lecture last night. And here we're talking about an efficient, effective, parsimonious inventory policy response to an increase in demand or increase in service level. Whereas both the reorder point and base stock level are directly related to demand, only the base stock level directly related to the inventory period and not the reorder point. So it's just really interpreting these values up here. See, here's the continuous review, there's the periodic review. Periodic review has the base stock level. Okay, there's no periodicity in there. I mean, there's no inventory period in there. That's what this is saying. But there is here. See, the ROP looks at, and this looks at this. Andrew, you're right. It is 450. That's what I was looking at. Somehow, I don't know why, somehow when I calculated this thing, I got 450 in the homework. So that might make, that very well might make, where was I? Darn. Oh, that might make all these wrong. I don't know. But if the mean is in each one of them, they probably will be. Anyway, for some reason, I don't know why, 450 should be it. I don't know why. Kind of makes me mad. Not mad, it's like, why don't I have it right? Tell you what, let's do this again. The average should be 450. And why isn't this 450? It is. Who knows what's going on up here? Oh no, you're right, 450. Bingo. Equals the variance, what I asked, the sample variance. So now this might be correct. I think a lot of times what this is the right mean and variance. So what happens is in Excel, sometimes, yeah, see? Sometimes this first one here, number stored as text, convert to number, bingo. You got to be careful. Well, Excel is very good, but you got to be really careful. Did you see that? See this little green here? Let me. This might. I'm kind of glad this happened. See, these cells here are just white, but this cell has a green. Now, when you click this, notice it has a message here. When you click the message, it's number stored as a text. Okay, and so if you average 2 through 10, you'll get this 447. But I want to average all 10, so if I convert that to a number, boom. Those are the right answers. Bingo. So that's the mean and variance. Okay? Great. Good job, Andrew, Evan. Good job. I hope this helps. So a lot of this, what I'm talking about here, is just putting in and seeing what the numbers are. Okay, and I don't. Some of them are right. Some of them may be wrong. I don't know. And down here, it's just the relationships. Okay, I'll go on. If you have any questions and go back, I'll go back. So I'm just working through this homework with you. Now this one, here's another. When I looked at this, then I realized I really didn't cover this in the lecture. I kind of want to cover it because this is a very common problem the numbers come at you commonly this way. That's what I mean by that. A distributor is re-examining one of their key inventory items because of historically inconsistent sporadic demand. Due to increasing short cost, a stochastic single period EOQ inventory period policy is being considered. Single period. Data from past orders were requested and received in the histogram given below, which is assumed to be normally distributed. Well, it's normally distributed. See how symmetric it is. Okay. So the idea here is that, commonly you say, what's the distribution? I need the mean and variance. Well, the mean is somewhere around 700. What's the variance here? Well, if you're given a histogram, how do you get the mean and variance? It's not that easy, okay? Well, that's what I wanted to do. Once we get the mean and variance, let's back up here. Let's get single period here. Bingo. Control C, come down here, Control V. Okay. Say, I need the mean, I need the standard deviation, and then the Z. Well, that Z comes from the short and long cost, right? And somehow it didn't copy through. Why didn't it copy through? Anyway, it's long over the long plus short. Okay. We need the mean and variance. Here's how you get the mean and variance. Now, some of you probably already know this, and I don't think I did it in the lecture, but I'll do it here. Okay. So first of all, let's reduce this down. You need two things. You need x, the midpoint of these intervals, and then we'll talk about the frequency. Okay. Well, the midpoint is given here, 500, 600, 700. And so this is 500, 600, 700, 800, 900. And then the frequencies. You can see the frequencies 25, 55, 95, 60, and 15. Okay. And so once you have this, I'm just going to go ahead and do this for you if that's okay. Let's change this to Arial. I like Arial better. It's a little bit more compact. So what we do here is we sum this, and then we want to calculate the probability. And that's just the frequency divided by the sum. F4 to freeze that. F4 will freeze it. And then just copy it down, boom, 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 and sum that, auto sum, and you see there's the probabilities. So now, if you have x times p, very simply x times p, and by the definition of mean, the mean is 694. That's the mean. Okay. But then you need the standard deviation. Well, that's a square root of the variance. Okay. Well, how do you get that from the? Well, here's how you do that. X times p. Whoops, p. Okay. So that equals x times p. And then we copy that down. And then we sum it. Okay. And this right here is not the variance. Not the mama. This equals the sum of the sum of square the expectation of x squared minus the mean squared. That's the variance. The standard deviation then is the square root of the variance. Boom. And so those are the two numbers you need. There's the mean. Whoops. There's the mean. There's the standard deviation. And now right here, there's the mean. There's the standard deviation. Right? Now you need the z. Well, to get the z, I don't have the equation here. I guess I should put it right here. Z then, bring this back up into reality. There we go. Is alpha equals long cost divided by the long cost divided plus the short cost. Okay. And so I don't have this here, but essentially those are the equations. Okay. And so what I have here then is 70. Where are we? Where are we? Okay, let's bring this over here. So alpha, let's bring alpha here. Equals the long cost, which is 704. Whoops. Divided by 704 plus I think you have this 96. Okay. Darn. I'm sorry, I have this backwards. It's the short cost. The short cost is what's the important one. Because the short cost is the one that's high. Okay. I'm sorry. The long cost is high. Darn. Okay, got it wrong. Equals the long cost 96 divided by 96 plus 704. I'm getting there. I thought I was right. Okay, and then this equals the normal standard inverse of, whoops, inverse of, that's the tail, so 1 minus that is going to give you your alpha value of 1.175. Okay, and then you add this. So the idea here is that's going to be bing plus that times that. Okay, actually that's how you do it. Just do the arithmetic. Okay, so I really didn't go over this, but it's a nice little trick to know, like tricks of the trade. It's something really nice to know, because I know when I was in industry, a lot of the stuff we got was just histograms. You know, it's nice if you have the data, but you really don't want the data if you have, oh yeah, we have data, there's about 30,000 numbers, can you give me a histogram, you know, can you give me a frequency thing, and then you could just pull it off real fast, just like I did. Okay, because you're computer people, you're IT and computer people, and they'll give you the history, they'll do that kind of stuff. They have software to do all that for you if you're a consultant. I was a consultant, so I would ask for things that I knew I needed. Okay, and then you do the arithmetic and see which one of those is right. Is that good, guys? We're good to go on? Okay, let's go on. Oh, and then I have the relationships here, you know, up and down, you know. Stock out level represents the probability of incurring a short cost. So that goes back to the lecture. Let's bring the lecture back up. In other words, this lecture down here, when I talked about the single period stochastic, let's see, where's that being? It's going to be, if I can find it here. What page is it on? Oh, I know. Base stock level. First I do inventory risk pooling. You're right. Then echelon inventory. And then single period. Okay. So here's where I talk about when it's used down here. Also I talk about the relationships up here. How when I've determined this, really I define the stock out level to be alpha, the probability that the demand is more than the lot size. That's the stock out level. That's the probability of stock out during this single period. So that's what that's talking about. These true false here. Okay, so that is just going back to the lecture to make sure you are comfortable with the language. Okay. Then risk pooling. Okay. Now we have, and notice what I did here. I say a distributor has satisfied 3 wholesalers' warehouses by managing 3 different inventories. Let's make this big. At 3 different locations, 1 for each wholesaler. So each one of these, it's kind of like 3 single demand streams that they satisfy to keep the same service level for each wholesaler, same service level. The distributor orders from the manufacturer every 2 weeks for each inventory at each location and receives the order 1 week after the order is placed. The distributor is considering placing 1 order every 2 weeks large enough to satisfy all 3 wholesalers from 1 inventory at 1 location. So essentially they're risk pooling is what they're doing. To analyze the change, weekly demand for each wholesaler was collected over the most frequent, and there it is. Okay. And then since the pattern of the weekly demand over the last few years has been consistently bell-shaped, a normal distribution is assumed. To distribute the feasibility of combining inventories, the correlation matrix for the 3 wholesalers was obtained. So essentially you take these and you do the correlation. Okay. As a matter of fact, if I take these, Control C, let's do it this way. Control C, let's bring Excel back. It doesn't hurt just to show how this stuff is done. Let's open a new window. Control C, and essentially what you want to do is highlight these and then come into the different things. You can do the data analysis, and this is an add-in. Okay, and then come down here for correlation. Okay, input range is going to be, let me just take all of these. And I do have labels. Output range, I just want this right here. Say go. And there's my correlations. And notice this is what I put here. Enlarge this so you can see it. That's all I did to get these correlations. Now the reason I did that, remember, here's the interpretation of risk pooling. When you go to centralize to distribute to multiple downstream demand streams, you're satisfying multiple demand markets. Then what happens is that the closer, and actually I refer to this on the B part down here. Okay, here, the closer the correlation is to a -1, the greater the savings. The closer the correlation here is to 1, the smaller the savings. Well, none of these are 1. This is negative. Okay, but this is 4.9. This is almost 0.5. This is almost 0.3, and this is a -0.03. So the point is that the closer the correlation is to 1, lower the savings. The closer it is to -1, the greater the savings. And so when you're looking at this, you say, should I go to the trouble of centralizing? When I look at this and say, oh, yeah, I can save some money here. And so if the unit carrying cost is this for each item over a week, then what is the total carrying cost savings by using 1 inventory instead of 3 at a 90% service level? Use sample standard deviation. Okay. So what I'm saying here is actually, like I did in the notes, go through getting the cost and then comparing them and subtracting them. In other words, let's bring up the let's bring this back, and notice down here, here's what we're doing on this one. Item economic, right here. Here's risk pooling, and this is page 17. So here I'm describing it, and here I derive it, but down here I give you an example, and it's this example that I'm really referring to in that problem. In other words, take take the values and put them here, here, sum them over here, and then get the mean, the variance, the standard deviation on these. And this is just the sum of the means, the sum of the variance, sum of the standard deviations. Okay? And then we're going to have 3 of these. There's 3 of them. Not 2, there's 3. Okay, then you say, okay, then what I'm going to be doing is coming back up here, is calculating the safety stock for each one of them. 1, 2, 3, and then all 3. Okay, and then when you do that, you calculate the safety stock, and then once you get the safety stock, then you're going to take the mean and variance. Let's see here. Let's back up here. Okay, the distributor is considering placing one order every 2 weeks, large enough to satisfy all 3 wholesalers from one inventory one location. Now, that sentence there is important. Oh, let's see. They're going to do it. They're going to order once every 2 weeks. Okay, so that's periodic. It's not continuous. Okay, so it's going to be a base stock level. And from the base stock level, we're going to calculate our costs and see how much we're saving by pooling it, ordering once every 2 weeks. Interesting. So if you're working for a company, you can do that every 2 weeks. Or you say, well, can we do it ROP? If we do it ROP, you can have ROP on all 3 of them, all separate ones. I don't know. But this is all in one, so we're doing the base stock level every 2 weeks. Okay, because now you don't have 3 different inventories. Now you have one inventory. And you could do ROP, but we're doing base stock level. It's a lot easier when you have risk pooling. Okay, so you calculate the base stock level, calculate the costs, the actual inventory costs, and you know what the ordering cost doesn't matter because the frequency is the same. Okay, and notice here, if the unit carrying cost is $12 for each item over a week, then what's the total annual carrying cost savings by using one inventory instead of 3 to 9% service level? So the ordering cost doesn't matter because you're going to order every 2 weeks anyway. It doesn't matter. The carrying cost is where the savings are. And you will save money with the carrying cost because you're using less safety stock. It's the safety stock that is where the savings are. Okay. Okay. So again, the technique you'll go through is basically this right here. You get these numbers, and then from here, I didn't do it here, but here, then like here, here's where you do your base stock level and do your costs. Just do the inventory costs over an inventory period and see what the savings are. Total annual savings over a year. It's every 2 weeks, and there's 26 2 weeks, so you do it 26 times. There's 26 2 weeks in a year. Okay, because there's 52 weeks in a year. So there's 26 inventory periods. Okay. Oh, and then I asked those questions. Okay, about the correlation, about your savings money. Where do you save it? It's in the safety stock. So I just asked different things here from that. Okay. And let's see here. You know, while we're here and we're looking at this, let's go to the website. Let's see what I have here. I know I have some stuff here. Yeah. Okay. I have an Excel file here for the quantity discounts, but I don't have any Excel files down here. Be nice if you had a template. I bring that up because I kind of want to. I kind of want to give you one. Darn. In other words, what I'm saying is, let's come back to the lecture. Let's come back to here. I kind of want to give you a template like this to go on and actually calculate the base stock level. I'll just do the base stock level, and for consistent inventory period, and calculate the cost to see how it works. Then you can use it as a template to plug and crank. Because once you go through it, you begin to see this stuff begin to happen, and it's helpful. Okay, let's go on. Oops, let's bring this over. Okay. Okay, then we have Echelon Inventory. Okay, Echelon Inventory is a little easier than the other. Less computation. Excel will do this quite well. So the idea, a manufacturing company controls its own, a manufacturing company controls its own distributor, wholesale, and retail store in a region, a retailer. In the past, each stage of the supply chain has developed their own inventory policy. The inventory policies and the information are given below, where all the times are measured in weeks. Okay, so you have the mean, variance, inventory period in weeks, order quantity, lead time in weeks, stock out level, reorder point, inventory policy, and there they are. Okay, the company is considered an echelon supply chain inventory policy for the distributor, wholesaler, retailer to improve efficiencies. In the inventory policies, the company wants to use EOQ and a 91% service level for each stage of the supply chain. Okay, so EOQ will probably change the lot sizes. The echelon inventory will change the ROPs. Okay, the following unit costs are obtained for the analysis. There's your ordering cost and carrying cost. Okay, per week and per order. Which of these is the correct one? Okay, so for this one, if you go back to the lecture, again, if I can go back to the Echelon Inventory, and notice what I did. I have this little table here, and you just fill in the table. There's only 3 stages again, and you fill this table. Here's a retailer. This is the wholesaler, distributor. So you have these things working together, and the mean and all these things. And so again, the ordering cost, carrying cost are different. The demands, I think, are the same. Calculate the EOQ, calculate the ROPs down here, and so you just use this table. That's what you use this table. So really, all I'm doing here is saying, okay, well, I'm giving you all these information you need just to put into this table, and just going through the mechanics and seeing which one of these is correct for the retailer, wholesaler, and distributor. I hope that's enough, because you have a template. And then I talk about qualitative things, about the lead time, reorder point, safety stock, what happens. Okay. Oh, now ABC classification. This is the last quantitative one. There's a couple of things going on here for ABC classification. An ABC inventory classification of 20 item inventory resulted in the classification 4, 5, and 11. Okay, I tell you what let's do. Again, let's bring Excel in. Let's type this in. So what we have here is we're going to have a classification of 4, 5, 11. So the number here is 4511. Let me type these in, then I'll make it bigger. The total annual usage, okay, let me call that M, is going to be 349852, 65156, and 25785 for ABC collectively. And then your ordering cost C sub O is 135, and then the C sub C is $4. Okay. Okay. So then EPP simply will be C sub over C sub C. It's going to be 33.75 as long as whatever our policy is. Okay, but notice what I say here. How many statements are correct? For an inventory policy of 2020, 14, 11. And so each time I give you the policy, 22, 14, 11, 22, 14, 11. And then the optimal inventory policy that minimized is, then I give you the optimal. Oh, then I say, is that the optimal? And then the inventory policy of this, which your annual, the minimum cost, well, okay, then you compare. Then you compare. Okay, so you have to go through the red book, the cost analysis. Okay. 22, 14, 11. 22, 14, 11. So this is the frequencies. And so remember, we have NF, we have this times this. I'll do it for you real quick. It's not too long, really. And then the average inventory equals this divided by the frequency divided by 2. Whoops. Divided by 2. And then copy these down. Bing. And then we sum these. Okay. Okay, and then what do I ask? Inventory policy, which is the total annual order frequency is. Oh, I think I just did it. Oops. Pulled the wrong one. I think I just did that for you there. Is it 279? Yes, it is. Oops. Okay. Well, the first one's true. Okay. That was easy. And then the EPP, which are the annual, is approximately 41. Well, I did that one too already. Oh, no. The EPP for the inventory policy of this, which are the annual order frequencies for classes A, B, C, respectively, is approximately 41 for the entire inventory. Oh. Let me show you what that means. So the idea for the entire inventory is this. Okay, and so we can do the EPP, the observed EPP, which is just the average inventory divided by the number of orders. Okay, and so copy this down. And so the question is, what is the equal average of these numbers? Okay, and I'll let you do that. So I won't do all this for you. Probably should. But it's the average of those. That's what I'm asking for. Is that about 41? Okay, and really I say about 41 because approximately it's not exactly. If it is 41, it's not exactly. None of these are exact. The optimal inventory policy. Okay, is that the optimal? Okay. Well, remember. Let's bring up the lecture. Here's the lecture. Remember, we have an equation here somewhere. Oh yeah, it's down here. Bingo, there it is. There it is. Let's go ahead and copy this and then bring this over in Excel up here somewhere. Let's see where the hell. Okay, and there it is. Let's justify this thing. Okay, close enough. We can. That's good. We don't need the EPP. We know what the EPP is. Okay. So what we do here is for the optimal F star equals the square root of the usage divided by 2 times the classification times the EPP, which is 33.75. Okay, and I think that's it. Boom, boom, boom. In parentheses, return. That's going to give you the optimal frequency. Do the same thing for the B class and the C class. Do the same thing. I'll let you do that. And is it 30, 10, and 4? Is it or is it not? Okay. For an inventory policy of 22, 14, 11, which is the annual order frequency for Class A, B, C, respectively, the minimum cost inventory policy will decrease the total inventory cost by approximately how much? By 8330, yes or no? So the idea here, let's move this out of the way. I know that the ordering cost is 135. I know that the carrying cost is 4. So let's take this times this, and let's take this times this, and let's add this up. And so that's that. The question is, if you take the optimal and put that in here, how much less is that? How much is that going to decrease? And that's what I'm asking here. What the minimum cost will decrease the total cost, inventory cost, by approximately that much. So what is the decrease? Is it 8330 or not? Okay, and so that's what I'm asking there. Okay. Now there are other applications than this. We may get into them later. I mean to see how much just classification. But since you're automating this and you have a model, the model can be used in a lot of different ways. This is only one way. And we may get into that later weeks, but we're just introducing these ideas now. And then I get into, again, the statements here. Okay. Now this is the quantitative and qualitative. I hope this is enough to help. I wanted to show you how to work some of these things, and I have a Zoom session. Oh, this is a Zoom session, but what's going to happen is we're not going to be able to have. I'm doing this instead of the Zoom session, so I will be. We're not meeting again until this stuff is due, and we probably should. So use the discussion board and talk amongst each other, discuss the questions and the problems. And if I get an email here and say we have some questions, then we'll maybe find a way to answer your questions for you, especially this week. This week I can see I've covered a lot of things. I probably covered a little too much, but that's okay. I don't mind that. We're learning a lot. We're learning a whole lot at the beginning, and then we're going to get all this information. Then we're going to start focusing as we get into the course. Focusing on very specific things, not all quantitative. Most of it's qualitative toward the end. some very interesting things on how this. Oh, the last one here. Consider each inventory policy approaches, briefly described below. Upload one-page report in a PDF file. In your report, identify and describe a commodity supply chain and present how one of these approaches would be effectively used. At the top of your report, center a title, Inventory Policy for Supply Chain, and your name. Well, say commodity supply chain, and your name. In other words, you pick one of these. All I'm saying is pick one of these. You say, you know, this commodity would be good for this particular type of supply chain. And say why. Okay? And that's all I'm saying here. And so on this question here, I just want you to think about commodity supply chains and then think about these different inventory policies and try to match them up. That's kind of what I'm looking at. How to match these things up. Okay. Well, that's the homework. Let's see if I have any chats here. Okay, Andrew. Let's talk about the add-in for correlation. Correlation, a lot of other things. Let's bring Excel back. Okay. The add-in is under data, but here's, and if you click data and you don't have it's the solver, that's optimization, linear optimization, or it's optimization, linear and nonlinear optimization. And then data analysis. Notice data analysis, they have a lot of different things here that you can do. Regression is used in Fourier analysis and exponential smoothing. Let's cancel this. This doesn't naturally come when you load it. You have to add it in. But it comes, you just have to add it in. You have to activate it. Here's how you do it. You go under File, come all the way down here to Options, and under Options you come down here to Add-ins. Boom. And then you come all the way down here to the Excel add-ins. Notice you have a number of add-ins here. Do Excel add-ins and say Go, and then it'll ask you, what do you want to add in? And usually the analysis tool pack, I use VBA. I don't use VBA in this course. I do it in other courses. Analysis tool pack is what I just used. And the solver add-in is optimization add-in, linear programming and nonlinear programming, etc. Integer programming and mixed integer. But anyway, and then you say OK, and when you do OK, then under the data tab, it should be over here under the analysis grouping in your ribbon, data analysis right there, and solver, data analysis. If you click data analysis, then it'll be right there. Okay, that's how you get it. Are we going to use Zoom at all, or will it mainly be YouTube? No, I want to use Zoom because I do want to discuss this material. Actually, I want to use Zoom every week. This should have been a Zoom session, but I wanted to do this YouTube instead. Okay. Now, as far as a Zoom session, or say office hours, conversation, for this week, we can have another time to do it. We can actually, I'm going to close this down and open a Zoom session. We can do it right now, which is fine with me, because if we go here, if we go to Canvas, if you want, you can just go right here and click the Zoom session. I'll open it up, and then we can have a Zoom session right now and just ask questions and talk about this stuff. Or come back to the syllabus. Another option we have is, notice I have Tuesday and Wednesday. Unfortunately, I am busy the rest of the week at night. I Zoom all the time with other courses. Now, we could have a Zoom session on Saturday morning or Saturday afternoon, or let's say Saturday morning or something like that. Either maybe Friday morning or something, or Friday afternoon. We could have a Zoom session another time. That's what I'm getting at. but I only have certain times available. So if you guys want to have another Zoom, a Zoom session, I've used the Zoom up. I can open up now, or I can open it up another time through the week. Because it's office hours, I just open office hours and answer your questions if I'm available. Because I have meetings. Well, I have meetings. Okay, I have meetings Thursday. I have meetings Friday. I'm at a seminar. I'm in a conference on Friday. I have a faculty meeting on Thursday. Saturday morning. And I go tonight. And Thursday and Friday night I go till like 9 o'clock too. It's all day long. Okay, sounds like industry, doesn't it? You just work all the time. When I was in industry, I just worked all the time. Got up at 6, went to bed at midnight. You know, that's the old industry for you. I was in the oil and gas. You just worked all the time. Weekends too. Well, weekends you're traveling. You travel. Then you have meetings. Anyway, I tell you what I'm going to do. Rather than wait for people to say things, I'm going to close this out. I'm going to close this live stream. I think I've kind of covered everything. Maybe not adequately, but I've tried to cover as much as I can to get you started. But what I will do, I'm going to close this out. I'm going to open a Zoom session, and anyone who wants to come, just come and we can talk about things and have a conversation. So that's all I have for now. And if you don't come in the Zoom right after this, then the next time we meet, I always want to say, be careful. Take care of yourself. Don't take anything for granted. Be safe, because I want to get through this and learn as much as we can, and it's hard to do that if you don't feel well. So protect yourself. Don't take anything for granted. Be safe. So I'll see you later.